I'm going to move it. Okay, so this is basically for DBF because since we don't have an aerospace program here, and since some of you haven't taken my elective aircraft building and control, including Trevor back there, I'm just going to go give you what I think is the minimum you need to be able to design, build, and fly an airplane. So let's talk about the airplane in general here. So this thing here is an airplane. And so let's just go over the major components. So I want to just do like a quick vocab lesson, all right? Let's see how much you guys actually know. So what is the long, like slender part here in the center, what is this called?
Fuselage.
All right, fuselage, okay? Then we got this whole thing, main wing. You aren't going to know this one. This whole tail structure put together starts with an E. It's called the empennage. I think that's how you spell it, maybe one G. And so you might know, what is this part of the wing called? The horizontal stabilizer. So here's the horizontal stabilizer. And then what do you think this one's called? Vertical stabilizer. Okay. These guys here.
Your turbines.
Your turbines, engines, nacelles. There's a bunch of different words for it. Engines. I think those are all the major components there. What are these little things here that kind of flick up? You know what those are called?
Winglets.
Winglets? Yeah. All right, so those are the major components of the airplane. Anybody know where the fuel goes?
In the wings.
In the wings? Rockwell, how do you know all this?
I'm smart.
Okay, sure. The fuel is in here. Why? So does anybody know why they put the fuel in the wings? Because it explodes.
Safer weapon pass.
So if I put fuel into the wing, what is that? That's going to change my mass. What else is it going to change?
Your center.
My center of mass, right? And so I want to put it in a place where if I remove it, it won't affect the center of mass. Because I want the center of mass to be somewhat around this vicinity. We'll get to that later, obviously. All right, let's talk about control surfaces. I'm gonna use this airplane here, and that way we can get a better understanding of all the different ones. Battery here. All right, so you guys are doing DBF. First rule: always turn the transmitter on first. Make sure thrust is down. Okay, Philip. What do you notice about the location of the battery?
Center of mass.
It's like, yeah, it's in a position so the center mass is pretty good. All right, so on a RC aircraft like this, you've got two control sticks. What does this guy on the left do? What are those called? The ailerons. Okay, so if I move the stick this way, this guy goes up and that one goes down. Why does it do that?
Changes the flow of the air.
Change the flow of the air, and so I get, what, less lift here and more lift here, and so that rolls my aircraft, right? So if we were going to write down like a road map or something, you would say that the ailerons affect the roll angle of the vehicle, okay? If I move the stick up and down, what's going to happen? What does that do? So if I pull up like this, what's going to happen to this? It's going to pitch, right? Yeah, so this is going to decrease lift on this guy, and since where's the CG of this aircraft approximately? Probably here, right? So if I have less lift here, so I have a downforce this way, what's that going to cause my aircraft to do?
Nose up.
It's going to nose up, exactly. And so initially, because I pull up, I'm actually going to drop a little bit because I've lost the lift, but I'm also going to pitch up at the same time. And then because, assuming I have thrust turned on, that's going to cause me to climb, right? So you have elevator, which controls pitch, and it can be argued that it also controls like your glide slope or your what is that called? It's called gamma. What is that? I forget what it's called. It's eluding me right now. Climb angle? Yeah, I guess you could call it your climb angle. And so if you want to pitch up, you pull back on the control stick, and if it's on, assuming you have enough thrust, you'll climb and you'll start to go up, right? So if I push down, I get the opposite effect there, right? So then on the left, I control this guy here. So this RC aircraft in particular has two effects. So if I'm on the ground, what do you notice this would help me do? It helped me steer, right? So this is called a tail dragger. A tail dragger because the wheel is actually on the back. There's other aircraft where the wheel's on the front. And what they do is they run a bar from the rudder, that's what this is called, all the way to the front of the aircraft to control the nose wheel as well. That way you can kind of taxi around in circles. On a full-size aircraft like this, the pilot would just have control over that wheel there to taxi around. And the only way for him to go forward is to turn on the engine. So if you notice, when the aircraft moves backwards, there's actually a truck that pushes it backwards because the engines can't go in reverse. And then he spools it up to 10-15%, and the aircraft starts moving forward, right? And so for this guy in particular, it's not a very good driver, but if I hit the left stick forward, I can get a little bit of thrust and kind of turn around. The problem is I don't have any brakes, so if you're not careful, you'll just run into something, right? Let's see, what else did I want to say about this thing? So then obviously we got elevator. So then that guy in the back is rudder. And what is rudder for?
Yaw.
So it's kind of for yaw, but not quite. It's you can't just rotate the aircraft like this, right?
Mm-hmm.
It's for two specific maneuvers. Keep thinking. I'm going to pull up the video. Where did it go? Here you go. You guys can't think of it? Okay, so what's happening in this video here? Why does the aircraft look like cocked to the side? Down in a crosswind, right? And so what's going to happen at the very last second, right before the pilot touches down? He's going to kick that rudder out and turn the aircraft and then land, right? So that's one reason for a rudder is to come on in, man. Okay.
Deuces.
Oh, actually, oh man, he didn't do it right. Imagine being on that plane. This is your captain speaking. I'm sorry, we're gonna have to try again. Anyway, so that's one reason. The other one is what's called a coordinated turn. So if I'm flying like this and I hit the ailerons and bang, what that's going to do to my lift vector is it's going to cause me to rotate this way. And so what I want to do is I want to kick the rudder out as well because I want the aircraft to do what's called a coordinated turn so that my gravity vector is pointing directly down this way. And so what you'll see is when pilots on RC aircraft, when they bank the aircraft to turn, they'll actually hit the rudder a little bit just to get it to be a nice smooth turn. Trainer aircraft won't even have a rudder because if the aircraft is what's called yaw stable, you won't even need a rudder. So what a lot of some like trainer aircraft will do is they'll have a dihedral, so they'll have the wings like up, or they'll have a V-tail or something like that. They'll combine the ailerons and the elevators together to get like rudder vons or elevons or elevators. It's like weird things like that. But those are the major components and control surfaces of an aircraft. If you have a bigger aircraft, you can get, let's see, where's that one video here? Oh, here you go. If you have a bigger aircraft, you can use what are called flaps. And so what would flaps be for? Well, they slow you down, but what are they? Where are they located on the wing?
At the bottom?
Well, what major lifting surface are they on? Are they on the wing? Are they on the tail? Where are they? They're on the main wing, right? And so if I deploy flaps, I'm going to pause this video so you can see them. I think it's yeah. It's kind of not. You can't see it very well, can you? So if you notice, this surface is down and that surface is down, right? If one was up and one was down, you would roll the aircraft. But if they're both down, you won't roll the aircraft. But what will you do?
Lift.
You'll increase lift. So it'll be harder for you to propel the aircraft forward, but you've increased your lift, and so this pilot can take off in a much shorter runway And since the F-16 is a boss, and it has so much thrust, he can take off, and then obviously it says crazy insane F-16 takeoff, so obviously something crazy is going to happen.
Mark on the tree.
Yeah, he's going to crash into a tree, right? Yeah. So he's going to just yank that elevator backwards and just fly straight up, right? So if you design your aircraft to have like a thrust to weight ratio of say like 0.5, which is half, you won't be able to fly straight up, right? Because your thrust will be half of what your weight is. But if you're an F-16, which I think the thrust to weight ratio is like 1.2 or something like that, you can go straight up like that and actually accelerate. I'm pretty sure this aircraft, am I still on? So that's obviously got a thrust to weight ratio bigger than 1, right? So I could fly straight up with this thing if I wanted to. This thing's awesome, by the way. Let's see, the last thing I want to talk about is this thing has what's called an internal gyro on it. And so an internal gyro, what it'll do is it'll measure the roll and pitch angles. And so I can actually flip this switch here and turn it to beginner mode. And so now, if I lift the aircraft up and do this, you'll see that the tail, or the elevator, will actually move in opposition to my pitch angle. And so if I roll it, my ailerons will move now. And the other thing is, not only is it measuring bank angle, but it's also measuring rate. So if I move quickly, you can hear the servos actually actuate faster than if I just moved it a little bit. So this gyro is reading absolute phi and theta, your pitch and your roll angle, and it's also measuring your angular rate as well, and it's applying feedback control based on that. So the DBF guys last year, they had a gyro on theirs too, a system in flight, and I think it's actually legal to have a gyro on your aircraft, which is really nice. Gyros are super cheap. They're like 15 bucks now. It's insane how cheap MEMS technology is. Okay, I think that's it for the vocab lesson. We got sensors, controls, states, flaps. Oh, let's go over aircraft types. Okay, so this is a conventional aircraft here. You got your passenger aircraft. You got your cargo aircraft. But one of the things that I want to point out in these two different videos is what do you notice about this empennage versus this empennage? So the vertical stabilizer, right? They're both in the back, right? But what about the horizontal stabilizer? Where is this one? It's at the top, and where's this one?
In plane.
In plane. Why do they do that? Anybody know? This one's got this is what's called a conventional T-tail design, but there's another like unconventional, T-tail design, or like top T, capital T-tail design. And the reason why they do this is because if I do a side view of the main wing, and say I'm flying at an angle and I've got a conventional horizontal stabilizer, right? If you're on a boat and you're behind a boat, what's behind that boat? What's it called? The wake, right? Well, air is a fluid just like water is, and so the airflow is going to come over here and you're going to get what's called downwash over here. And that downwash is going to hit that tail. So during the design process, what some people will do is they'll just move the horizontal stabilizer above that so it doesn't get hit in the downwash there. Now, what the pros and cons are, I'm not entirely sure. There's probably some structural stuff in there, but I just want to get you an idea that there are more than one way to build an airplane.
Wouldn't that increase the lift across the tail if it was at the
If it was outside of the downwash, it would, yeah. Let's see, stunt biplane. So why do you have a biplane? Why would you have two wings there? You're going to get more lift, but why don't you just make the wing longer? Or fly faster?
Makes it more unstable.
Well, what kind of unstable? If I make the wings like super, super, super long, what's going to happen? They're going to start to flex like crazy, right? So it's a cheap way to just, you're increasing weight too. Like everything's a trade-off. You could make the wing longer and then you have to beef up the wing structure. Or you could make it a biplane, but then you've got these connected surfaces here, so you have all this weird aerodynamic interaction. Everything's is a trade-off there. So the DBF guys last year, they decided not to do a biplane because how can you put an aircraft inside of an aircraft when it's a biplane? That's tough, which is why they went with the flying wing. I should probably show you guys what they did last year, shouldn't I? Where would this be? Let me do that. South Alabama, DBF, results. recap, click here. Yeah, there you go. So there's the aircraft there. So that's the big plane, that was the production plane, and then this was the manufacturing support aircraft. And so their criteria was this airplane had to fit inside that one, and every single foldable surface and detachable surface counted as a component, and that counted against you. It was just like golf. So they mounted their propellers inside the wing so that they didn't have to take off their propellers or fold them. And then they made the entire aircraft look the same as the bigger aircraft, so it literally, this split into two pieces, and this one inside is sandwiched together. It's a pretty ingenious design in my opinion. But again, what is this type of aircraft called?
Flying wing.
Flying wing, right? So the whole thing is a lifting surface. Now what's bad about flying wings?
Their center of gravity.
The center of gravity is kind of finicky, and their center of pressure, or where it lift acts, is kind of finicky. And it turned out that when they were flying in competition, that was kind of backwards, and the whole thing flipped upside down and things like that. But again, we'll get to that. Let's see. You got fighter and attack aircraft, UAVs. Okay, so this is your realm that you're going to operate. We don't really know how big they're going to be, but they could be as big as your hand, as big as your body. Real turbine jets, which I don't think we'll get funding for that, but that'd be cool. And then this is we call this guy Clifford because he was red and white, and I think that one had like a 6-foot wingspan. You can get an idea of how big this aircraft was. I mean, I think that was like 8 or 9 feet wide. It was pretty big. Let's see what else we got. Connected, blended wing bodies. Yeah. So here's like your flying wing types. You know, so there's like some Boeing concepts, and then you got the what is that? The bomber? I forget what that is. Huh?
Battery.
Oh, battery? Jeez. Okay.
16.
I know. That would have been nice. No, I'm just gonna drag and drop here. Watch this not work, and then we lost the one. And we're back. Did we do that again? Good. All right. All right, what was it? All right, yeah, you got the bomber aircraft here. Then let's see, helicopters. I think I'm gonna skip all of the helicopters and rotorcraft and the tilt rotors because there's no way that you guys are gonna do that. What happened? Oh. And then I'm gonna skip the flapping ones. Oh, tail sitters. This is kind of neat. You guys could potentially make something like this, right? So it would take off vertically and then pitch forward. You guys seen the Google Wing project?
Yeah.
No.
Awesome.
Or I guess Project Wing. So yeah, so it takes off vertically just like this, and then it just slowly transfers to forward flight. I'm just trying to give you guys ideas for different types of aircraft that you can make. Look at this guy, chief engineer, wears a t-shirt to work. And if you notice, there's 2 props on top of the wing and 2 props below the wing. And they do that because you need to be able to control pitch with just the rotors. And then it transfers to forward flight, and it's a flying wing, so the entire surface is a lifting surface, which is really nice. Again, another really ingenious design. Let's see, projectiles, parachute, it's lighter than aircraft. All right, so I think that's it for the intro to aircraft. If we want to like pause the video and move on to the next section. Does anybody have any questions?